150 megapascal. So therefore, all right, the normal stress max is equal to twice the radius of the circle, right? Twice the radius of the circle, which is equal to plus or minus 150 megapascal. Okay. And this condition, if and only if stress Z is equal to what? 0. We have to remember, stress Z over here has no value over there. Okay. So now we are going to construct Mohr circle. Okay. And I like to highlight this. The anchor point right is your what? Stress Z point. Right? Because it's 0 stress. Okay. So this is my point. I'm going to label this like what we have before. This is our point X. This is our point Y. And over here, this is our point Z. Okay. So now we're going to construct a 3D Mohr circle. Yeah, we're going to construct 3D Mohr circle. And I'm going to label, I'm going to introduce you some other stuff. Okay, I'm going to introduce. So we're going to draw, okay, normal stress. Okay, so it's going to be minus 200, 180, 160, 140, 100, 80, 60, 40, 20, 0, okay, 20, 40, 60. I'm going to draw more for you, okay? 80, 100, 120, 140. And I'll stop at 160. I'll tell you why later on. Okay. So we go up to 160. And then over here, we're going to have our shearing stress. Element rotating clockwise at the top. So like 2D Mohr circle, 20, 40, 60. And I'll stop at 80. Okay, we can stop at 80 because again, we know that tau max is equal to 75. Then minus 20, minus 40, minus 60, minus 80. Okay, so the element rotating anti-clockwise. Okay, you don't see this in a lot of books at all. In fact, you can't see it. Okay, I'm going to draw a box. Okay, I'm going to draw a box. And I'm going to draw the box in red. Okay, I'm going to draw a box in red. This box will have this limit. So we'll have a limit of 75, 150. Okay, so this is a box. If your circle go outside the box, right, where the shaded region is known as failure. Your not failure, will yield. If your circle go outside the red box where I'm shading now, your material will yield and your design will fail. Okay. Why in that box? Because this is minus 150. This is 150 in normal stress. Shear stress is minus 75, 75, 75, and minus 75. So that is the box that we have to operate in. If the circle go beyond that, the material will yield. And we would not want our material to what? To yield. So what we have just done down here, what I've just done down here, like what you have seen down here now, is we have combined Mohr circle with stress strain curve. I repeat again, we have combined Mohr circle with stress strain curve. What do I mean we have combined with stress strain curve? So if we were to draw stress strain curve, element or strain and stress, we know that over here this will be our what? 150 megapascal on the stress strain curve that I've drawn that you cannot see now, Eugene, come on, right? That is our stress strain curve. So how is stress strain curve relate to Mohr circle is this way. So we cannot go beyond the shear of 75 and the normal stress of 150. Okay, so let's start solving the problem. So we know that one of our stress state is at 70. Okay, one of our stress state is at 70. So I'm going to draw the 70 line. Right, we're going to draw the 70 line. Okay, and then the shear is at 40. Okay, so we know that that is our shear at 40. And if you were to look at point X, okay, point X, the element will rotate in a anti-clockwise due to the 40. Okay, so anti-clockwise is at the bottom. So from here, we know over here, this is our point X. Okay. So the next thing that we know is the radius, right? The radius we can achieve is 75 megapascal. Okay. So we know the radius, right? So we know there are two possibility down here. Okay, there are two possibility. One possibility, right? When I say there's two possible average stress position. Okay, so where is it yet? I don't know. This is just a sketch. Okay, so one of it can be here, right? Then the other one. By the way, this line I'm drawing now is not accurate. Okay, this is just a sketch. Okay, so I'm going to wait. Hold on. Hold on. I'm having some issue on my end. Unbelievable. Okay, so this point now, I'm trying to flip this, rotate. Yep, I got it. Okay, so there's another possibility that this is the other something has changed. Hold on, sorry. So I'm going to copy. I'm going to go paste. I'm going to flip. Right. So there's a possibility that over here, this is my O1, center of my circle 01, and center of my circle 02. Okay. And it's governed the radius. So this line I've just drawn, right? This line I've just drawn is the radius of the circle. Okay. Right. So we are going to find what we're going to find is we're going to I'm going to call we're going to find our I'm going to call this position from here to here. Right, W, and then from here to here is also W, is the same distance, right? So we're going to calculate our stress average one, O1 and O2, right? O1 and O2 are our stress average, okay? So we're going to calculate our stress 1, right? And our stress 2. So it's equal to minus 70 plus or minus, right? Plus or minus what we call W. Okay, so it's equal to minus 70 plus or minus W is equal to what? It's equal to 75 squared minus 40 squared. You can see my working. I do apologize. I'm drawing below. Okay, let me zoom bigger now. I'll zoom out so you can see. Okay, right? So this will be equal to, so is it 70? Yep, 70. So 75 squared minus 40 squared, okay, square root. So it's 63.44. So this is equal to minus 70 plus or minus 63.44. So one of the stress average point, right? One of the stress average point is equal to minus 60 plus by 63.44 is equal to minus 6.56. And the other one is minus 70 plus by 63.44. Okay, 70 plus 63.44 is equal to minus 133.44. Okay, right. So we found where our stress average is now. So I'm going to draw more precisely where our stress average now from here. Okay, so I'm going to sketch our more precisely where our stress average are now. Okay, so we know that this line over here, something moved. I really not enjoying Microsoft Notes now. It's moving stuff around for me. It's my fault. So this is 75. Okay. So now we have precisely calculate where our stress average is. Okay. So one of our value, we'll get rid of this. Okay, I'm not going to touch that. So 63 point what? One is at 6.56, so 6.56 somewhere around here. Okay, and the other one is 133.44. Okay, so 133.44 is somewhere around here, right? And we know that is our stress average. So stress average, okay, and that is our the other stress average. 2, and this is 1. Okay, and then we can draw a straight line from the stress from point X, right? Cutting the stress average and make sure it reaches the other shear point. Okay. So now this one over here, this is your stress. This is your Y1. Okay, we call it our Y1. Okay, and the other one, right? The other one, when we draw, you'll see a problem now. Okay, this is our Y2, right? Okay, and you realize that our Y2 is bad news. Yes or no? It's outside the boundary. Okay, outside the boundary. So from here, right, we know what we have calculated is we know this distance. The distance from here to here. We also know the distance from here to here. Right? So this distance is our W. Right? The W that we have calculated in the formula, right? And then the other side. Okay, so from here to here to point Y, that is also our W. Okay, so this is our W also. So let me draw a vertical line down. So that is our W. Okay, and then we draw another vertical line down. From here to here. Sorry, it's the computer. And then another one. Okay, so all this distance down here, so this is W, and this distance from here to here, that is also our W, right? So now very easily we can calculate stress Y. Okay, so stress Y1 is equal to minus 6.56, right? Because that is stress Y1 plus, because it's going towards the right, 63.44. Okay, so minus 6.56 plus by 63.44 is equal to positive 56.88 megapascal.